Hello students, this is another video on the same topic, that is support reaction. So the question is there on the board. See the beam here, again a simply supported beam is there with two loads. One is an inclined point load of 80 kilonewton at an angle of 30 degrees with the beam, and another point load of 40 kilonewtons at point D. Now if you can see the supports at A and B, support at A is a hinge support and at B is a roller support. So first of all, we'll draw the free body diagram. So free body diagram, that is FBD. First of all, the horizontal line which represents the beam, and see here, since there is an inclined load on the beam, so whenever there is an inclined load on the beam, at hinge support you have to show two reactions, one a vertical component and another a horizontal component. Okay, always remember, whenever there is an inclined load on a beam, on a simply supported beam, the reactions at the hinge support, that also you have to remember, at the hinge support only you have to, there will be two reactions, vertical and horizontal both, and at the roller support you have to show only a vertical reaction, that is R. Okay, now I will do resolve this inclined force into horizontal and vertical components. See, since there is 30 degrees, this will also be 30. So at C point, which is at a distance of 3 meters from the left hand support, that is A, first of all we will show the vertical component, that is 80 sine 30, and the horizontal component will be in this direction, that is 80 cos 30. Okay, and at D another point force is there, so the distance is at 2 meters, this is again 3 meters, this is B point, C and D, and this one is A. Now we have to find the reactions VA, HA and RB. So how can we find? By applying the conditions of equilibrium. So applying conditions of equilibrium. First condition, what you have to take, taking moments about A. Always remember, whenever there is a simply supported beam, you have to take moment about its left hand support, that is A here. Okay, so about this point A, summation MA equal to 0, clockwise positive sign convention and anti-clockwise negative. So from point A, how many forces are there on the beam? Vertical forces are 80 sine 30 at C, 40 at D and RB support reaction at B. So we have to take the moments of all the three forces about point A. So first of all, consider 80 sine 30, which is acting at the downward direction at C. If you try to turn it towards point A, it will turn in clockwise direction, so positive sign, and the moment is force into distance. The distance of this force from point A is 3 meters. So therefore 80 sine 30 into 3. Put this in brackets. Consider the second force, 40, turn it towards A, it will also turn in clockwise direction. So distance of this 40 from A, total distance is 6 meters. Since it is turning in clockwise direction, again consider sign convention of clockwise is positive, so plus 40 into total distance is 6. Now support reaction at B, it is acting in upward direction. So if you try to turn this towards A, it will be turning in anti-clockwise direction. So you have to take minus sign. And the total distance of RB from A is 8 meters. So RB into 8 within brackets equal to 0. Don't forget to keep brackets. Okay. Now when you solve this in calculator, this value you will get 360. Minus 8 RB is equal to 0. So 360 is equal to 8 RB. 360 upon 8 is equal to RB. Therefore, the value of RB will be 45 newtons, kilonewtons. Since the unit of forces acting on the beam is kilonewton, so you will also get this one in kilonewtons. So 45 kilonewtons, that is the value of reaction at B, RB. Okay, now we'll find VA and H. So now take second condition of equilibrium. So that is, first of all we'll take summation Fy. So summation Fy is equal to 0, vertical upward positive, downward negative. So summation Fy, what is the meaning of this? You have to add all the vertical forces acting on the beam, including the reaction forces. So VA 80 sin 30, 40 and RB. So since VA is acting in upward direction, positive sign, 80 sin 30 in downwards, so minus 80 sin 30, 40 again downwards, minus 40, and plus RB is equal to 0. So VA minus 80 sin 30 minus 40 plus RB, we got 45. So put the value of RB. So VA minus, when you solve all this using calculator, you will get this, the value of this 35. So VA is equal to, bring this 35 to right hand side. So you are getting VA 35 kilonewtons. Okay. Now the third condition of equilibrium, that is summation Fx equal to 0. Sign convention, right side horizontal positive and left side horizontal negative. So what is the meaning of summation Fx? Whatever horizontal forces or reaction forces acting on the beam, you have to consider those. So let us start here. See, there are only two forces, horizontal force. One is HA, reaction force at A, and one horizontal component at C. So HA is acting towards right side, positive sign. So HA positive, and this one is acting towards left side. So minus 80 cos 30 is equal to 0. You will get HA is equal to, bring this to right side, it will become positive. So HA is equal to 69.28. You can calculate using your calculator. You will getting 69.28. Okay, so we got both HA and VA. Since these two are the components, right, reaction components, if you want to find the resultant reaction, that is RA, so let us see how to find RA. Now for RA, the formula is square root of VA square plus HA square. That is equal to square root of, how much we got the value of VA? 35. So 35 square plus HA 69.28 square. On solving this, you will get RA is equal to 77.61 kilonewtons. So this is the value of reaction at A, and the direction, that is alpha, is equal to tan inverse summation VA upon HA. So that is equal to tan inverse modulus of, what is the meaning of modulus? If you are even getting the values of VA or HA or both, negative values you are getting, you have to put positive, or it will become positive since you are taking in mod. So VA is 35 and HA is 69.28. So alpha is equal to 26.8 degrees. So this is the value of direction of the reaction. So in this way you can find the support reactions of this beam. Okay, I hope you understood. Thank you very much.